Okay, unmute myself. Just give me 1 second. We're talking tonight about the Practical Object-Oriented Development in Ruby book by Sandy Metz. And we have 4 panelists who've each chosen a topic that they would like to share their thoughts on. And so we'll kick off with each panelist talking about their topic, and then we'll open up the floor to Q&A and discussion. So I'm just going to go down the list. Ezra, I'll have you up first if you want to kick it off for us.
Oh dear, I can. So I'm Ezra Shimon Rosenfeld. I am a Ruby on Rails developer at Cover My Meds, a healthcare company in Ohio. I've been there for a few months. Until that, I was working at B&H Photo in Midtown, where I was doing web development using Java and jQuery. So actually, at my current job, where I've been for 2.5 months, I actually haven't written any code yet. And I also haven't had time to code in my free time. So it's a strange time for me to be on the panel. I've been working through this book, which is incredible. But it's just strange times. I haven't written so much code. But single responsibility principle. I didn't exactly plan to monologue about it, but I can go for it. I see on the document here we have why that chapter, how I use it, and what are the benefits. So why the single responsibility principle? So I just read this book for my first time. I haven't exactly finished it, but I've been reading it, and there's a lot of new stuff in there. I thought I knew object-oriented programming, and like I've been working with object-oriented languages for a long time. I was in college for 3.5 years using Java. I was using Java for 4 years at B&H. And the single responsibility principle is something that I always thought about when I was writing code. But reading through this book, I realized that it's so much deeper, and there's so many more ways you can write better object-oriented code than I realized. So the single responsibility principle is the most, I think, basic principle in the book, and it gets more complicated, deeper into more complicated object-oriented topics. So I figure I start with the simplest one, especially because I haven't really been writing so much code in the past 2.5 months, but also because I hadn't read the book, so I was really just doing my best with the topics until now. And now that I have the book, I have more information. So I mean, I guess I'm just going to describe a little bit about what the single responsibility principle is. And I mean, basically, every class should have a single responsibility. I think the chapter is called Designing Classes with the Single Responsibility. Certainly, it applies to methods also. And I guess the way I think about the single responsibility principle changed a little bit when I read the book. So I used to think about it that every method should basically be doing one action. And every class should represent, I guess, one kind of object. So Sandy Metz talks about it a little bit differently. Sandy Metz talks about, I guess, behavior over data. That it's not as much that the class is representing one actual object, that it has certain data it's representing. It's more the behavior. You expect classes to do certain things. And she has, I guess, a little bit of a funny way for testing, well, is this class following the single responsibility principle? And the book uses the example, I guess, of a bike and gears. So for example, like if you're talking to a gear and you ask the gear, hey, what's your and I don't remember the exact examples. What's your ratio of cogs to teeth or something like that? And like, does it make sense to ask the gear that question? And then like there was another example, like, okay, Mr. Gear, what are your gear inches? And well, like using the word gear inches, it gets a little bit more confusing. Does it make sense that a gear would know its gear inches? Well, that sort of makes sense, but why are you asking for the gear? It's gear inches. And then, but just about how I use the single responsibility principle. So in the past, I knew about it. I hadn't read about it as it appears in the book, but I guess the way I would use it is I would try to just separate out parts of the program so each method was doing one thing. So like, for example, something I saw in code at work at my previous job was there was a method that it uploaded a file to a server from the user's computer. It updated a database record for that file, and it purged the CDN so that the image for that file will be updated. And it had a bunch of code to do all those things in one method. So, oh, everyone's gonna introduce their topic, and then we'll do, okay. Yeah. And then, but yeah, just the benefits are that it helps with code reuse. It helps with code reuse, and when everything has a single responsibility, it's easier to reuse it.
Sorry, it was a little unclear at the end. What helped
Yeah.
with code reuse?
So what we're gonna,
So
yeah, go ahead.
yeah, so I mean, I might get into this more later, but the single responsibility principle basically it helps with code reuse in that if every class has a single responsibility, if every method has a single responsibility, it's more clear what it does. It's easier to reuse it in other places.
So just to kind of set our what we're doing, we're going to go around to all of the panelists and let them just quickly introduce why they chose their topic. And we want to get everyone involved in the Q&A and discussion so we could jump into some more finer points of, say, single responsibility principle, you know, after everyone gets their turn. So we have JJ doing managing dependencies, Oscar will be doing inheritance, and Joe's going to be talking about some other books that have influenced him. So JJ, take it away about managing dependencies, please.
Sure thing. Sure thing. Yeah, I'll just introduce the topic. First, I'm JJ Seymour. Nice to meet y'all. I'm a software engineer for Epsilon. Andrew's actually my boss. We work with Ruby on Rails and Angular each day. I've been there for about 4 years, going on 5. And before that, I was an assistant instructor at the Flatiron School. And for me, actually, after going through Flatiron and then working there for a little bit, this was one of the first books that I picked up and really started to feel like, okay, Ruby is clean. It feels right. It's more written for people than it is for machines. And really, this chapter on DI was that like breaking point for me where I was like, oh, it's not about the objects that you're creating, it's about the messages that you're passing around and how can you pass them around properly. And that's something that Sandy tries to promote in just about all of her talks and all of her books is you're not building objects to encapsulate messages, you're building messages and building objects around those. Yeah, and we'll get into, you know, we'll get into the weeds of the managing dependencies section, but the one part, if you were to walk away from this chapter, just like knowing one thing, it's the breakdown, like a checklist of basically deciphering where are these dependencies happening. And we can talk about the checklist later. I don't know how much, Richard, you want me to go into. I don't want to.
That's great. That's a great intro.
Great.
Because then we can just kind of, you know, get people involved and open up the discussion, get in to some of the weeds, as you put it. Oscar, you're going to tell us why you chose inheritance as your topic.
Okay. Hello, everybody. I'm Oscar. I am currently learning at school, at launch school, for full stack fundamentals and with the Ruby track. And so I'm a student right now full time. Prior to that, I worked in biopharma as an engineer in making sure your medicine gets made correctly. But I didn't want to do that anymore. So I'm transitioning into tech. Pretty proud of the fact that I graduated with a degree in animal science and got myself into an engineering position. So I would say I have pretty strong problem solving skills. So I don't have any career experience with Ruby, just only what I've learned, but I just recently entered a hackathon sponsored by New Relic, and I won the overall prize. And part of that was just reading the Rails documentation to build a simple database where our application could store the data that we use for our application. So that was pretty neat. I learned that all in one night and got it working good enough for a demo, which ended up winning. So pretty proud of that fact. And as for the book, I chose the inheritance chapter because OPP, Ruby is written for OPP, but it's really easy for me to test inheritance to see if something's going wrong or as expected in the Ruby terminal. So that's why I chose inheritance.
Okay, cool. Joe, you're going to talk to us about other influences besides POODR.
Hi, everybody. I'm Joe. I run a company called Def Method. We help companies continually reach unrealized possibilities by building outstanding software. And I'm the kind of I'm taking the role as kind of the old guy in the panel because I started writing Ruby in about 2009. I can't put an exact date on it. The co-author of The Well-Grounded Rubyist, 3rd edition, and I'm a former Gotham Ruby Conference or GoRuCo organizer for anybody that lived in and around the New York area. I do live here in New York City. I'm sitting in my office, which is around the corner from B&H, just to let you know, Ezra. I pass it almost every day. Yeah, I mean, my topic is not necessarily other books, but it could be. I'm sitting next to this. I just pulled from our library like this stack of Ruby and object-oriented design kind of books, all of which had some measure of influence on me over the years. And when I was invited to speak on this panel, yeah, domain-driven design is there. When I got invited to speak on this panel, I just thought, wow, this book was so influential, and it got me thinking too, well, why is that? I mean, it's a great book and it was written really well, but beyond that, there are actually a lot of really well-written books that did not take off. So why did this one take off, and why did it grab everybody's attention? And so I was there at one of Sandy's first talks at GoRuCo in 2011. She, the first edition of POODR was published in 2012, and it hit. I could talk all day about this, and I won't right now, but I really think that it hit a niche that was as yet not covered by any of the books that came before it, and so I'm happy to talk about any part of the any part of the book or about the history of the book, and would love to dive into those topics. Yeah, that's me.
Okay, cool. All right, so this is a time for everybody to talk about. Well, you could direct your Q&A or your discussion about the topics that have been mentioned. They've been chosen by our panelists. We have the single responsibility principle by Ezra. We have managing dependencies by JJ. Oscar inheritance, and Joe was talking about his influences of other text and the POODR book itself. So I'll just kick off one quick question, and you guys just get involved however you would like to. This is your panel. This is your discussion. So Ezra, I think you mentioned this. You're going pretty fast. Why is the SRP principle important? Why is the single responsibility principle important?
Yeah, sure. Sorry about that. Really, I think reuse is the main thing. So I thought of a little bit of an example to explain how it's important with reuse. So let's say you have a method which does two things. It reads an object from a database, and then it manipulates the object, the object's data, to take a different form. Like maybe you're taking it out of a database and it's a string, but you want to read it into an enum or whatever it is. So if there's like one method that does both of them, and you need to read the object from the database and then take it into a different form, then either you're going to copy the first piece of code and change it because the method that you need doesn't exactly do what you want, or worse, you're going to reuse that method, and then the object that you need isn't exactly in the right form, so you're going to write extra unnecessary code to change it into the form that you want, when really the way you read it from the database, there was no reason to read it that way, and your code is just more confusing. So it helps you actually reuse code, but it also makes your code better in the long run when you do reuse code.
What did they say about optional parameters and methods for a single principle?
So that actually reminds me of a different part of really in the intro to the book. And one thing that Sandy Metz talks about a lot is designing too early. So something that I've seen in some code bases is people, I guess, writing code that they expect is going to be used in so many different ways, and they add in parameters for more ways for it to be used than they actually need at the time. So like in the intro, Sandy Metz talks about the whole point of design is that it's easier to change code later, and you only want to write the code that you need up front. I don't know if that answers your question. I don't know if anyone else has anything else to share about that, particularly, because I'm sure there's a lot of complicated issues that come up in the book, and I don't know if that one specifically is narrowly about single responsibility. But also, if anyone else has anything else to share about that, please.
Ezra, I think what you said hits the nail on the head. And she definitely mentions that, yeah, you don't code as much as you can, don't code for the future. But also it depends. I mean, with most things in code, it depends. Like it depends on what those optional parameters are going to be. Are those optional parameters going to be a list of objects that you have to go through and you have to do things to, in which case it's probably closer to handling it with DI instead of single principle. So it really depends. In DI, she definitely talks about how you want to, as much as possible, keep everything specific and clear. So when you're passing in any arguments, you're passing them in as a hash, and you're decoupling them as a hash. And later on, when she talks about like duck typing, when you're passing in like a list of different objects, you're passing them in as, it doesn't matter what the type of object is, but you're still passing them all in as an object instead of just, broken out into individual objects that you're passing in one by one. So I know that's the most like generic, like, well, it's a bunch of different things, but that is kind of unfortunately how it is.
I love how she, emphasizes in many places to, you just, I guess, specifically in that chapter, Ezra mentioned this, but talking about you know, phrasing the asking, being an interrogator of your object to about its behavior and to see where things fit. So in the case of, you know, optional parameters, I mean, maybe that answer becomes apparent if you follow that guideline of just for all the behavior that the object in class encapsulates, to simply interrogate it to see if they fit together.
Thank you, guys.
All right, so this is a question that interests me a lot, Oscar, about inheritance. What makes a good candidate for an inheritance hierarchy? I think this is like, I mean, certainly this is something I think everybody struggles with, you know, when they're trying to figure out these different things. But I would be interested to hear what you have to say about what you think about that.
Similar to how the book has a hierarchy, and I like to think of the parent or the superclass as the general term that general parent that can encapsulate all the subclasses or all the children. So that way, when all the children have the most basic methods or behaviors from the parent. So that's how I envision it. So I like to have I guess what's pretty shallow inheritance, so it makes things less complicated, keeping track of all the inherited behaviors from the superclass. And the nice thing about Ruby is that it has a single inheritance. So you only have one parent to inherit those behaviors from. So again, one parent, one superclass, and multiple children, like a nuclear family. And yeah, I think that's the pretty nuts of it. If I want different behaviors, you can overwrite methods, which can then get tricky. And if you inherit class methods or class attributes, and your child class inherits those, then you can cause some havoc with the parent attributes. So I guess with inheritance, you just got to keep track of what you're getting, you know. So that's why I like to keep it shallow.
Shallow is definitely good. One of the things that always confuses me or interests me is, like, you know, choosing between the different choices you have, the ISA, the HASA, you know, composition versus inheritance. And then, you know, Ruby gives us this really cool thing with modules and mixins, you know, behaves like a. So it'd be fun to maybe, you know, hear your thoughts on that, or anyone's thoughts about, you know, making the choice between all of these options.
Yeah. So to reinforce these principles, I kind of made myself a little D&D character sheet to help with you know getting a subclass and a superclass. So I like to think of it as like, is this a person, and are they like an elf or like a half elf, and what makes them different? So then you overwrite the behaviors that they're going to have, right? Or maybe one of my characters might have an optional or an additional parameter, and then the keyword super comes into play to how to differentiate that same method or behavior. Even though they're similar, that additional argument can be incorporated with that method that it inherited from the parent. And then modules I like to think about are behaviors that are not necessarily unique to either the parent or the child class, but might be beneficial for them to have. And so that's why you can add it into or mix it into a class and use it as a mix-in. So I think it's very neat. And with inheritance, if your parent class has a module, your child also inherits the module behavior. So it's like I like it because I can keep track of what's going on really simply in when I'm testing my code in the terminal. Like it's very like, oh, the parent has this method. Does the child have this method? Check. Same thing with the module. The parent has a module method. Does this child has it? And I can just check that, right? It's really easy. So that's why I like inheritance, even though it seems complicated or it can get messy really quickly. It's kind of like you have a potent tool and you just know how to use it. Like I do woodworking, so a lot of tools in woodworking can hurt you, but if you use it correctly, you can make works of art. I think that's easier for me than actually where I struggle a little bit more with OPP principle is writing a loosely coupled code. I tend to make things very tight, and I think that's harder for me to test for because I feel like everything's important and it has a relationship. So it's harder for me to test for that as opposed to inheritance. I can check that really easily.
Cool.
Well,
I don't want to ask all the questions, so please, everybody get involved,
well, I think, I think there is a question here about inheritance versus composition. And yeah, I like what Oscar had to say. I really feel like inheritance is the big, I've kind of always felt like it's the big hammer because you can only use it once. And that's kind of true for a lot of languages if you're coming from, from Java, from C#. But the thing is with Ruby, modularization makes things so flexible that I would, and I think, Richard, you already pointed to this, keeping a flat inheritance tree is usually better. And I think we feel like that because, even going back to the start of this, where Sandy is talking about, well, we're always trying to code with the future in mind. Well, in the future, you may need to use inheritance, right? We may need to build in and inherit from something or, create a super object. But if you can avoid it now, then we try to. And so I went along that path maybe too far and, realized that actually there are some places where, inheritance is important. I think when it comes to metaprogramming, when it comes to framework building, certainly, Rails sometimes it gets a bad name because it makes too heavy use of inheritance, but actually I think there are places where it does inheritance in a very smart way. And I think that's a good way to look at it. Like if you are building code with the idea that other people are going to use it for other purposes, it doesn't have to be framework code, but it will be repurposed, then you may build it with inheritance in mind, or even use inheritance in the structure of the program.
I'm just,
can I cut in real quick?
please.
So I just want to thank Sebastian for writing in the chat and remind everybody that we're all at different levels. So when we just started talking about inheritance versus composition, I'm like, I don't know what composition actually means. Like now that you defined it, I'm like, oh, okay. But like just the terminology, it's like, I don't have my tech dictionary handy. So, and like for whoever watches this later might be like, wait, what? So try to like define things as we go too, if you don't mind.
Yeah, thanks. Thank you,
Good
Meg.
point,
That
yeah.
is a really good point.
Thanks.
I'll try to keep that in mind.
So I haven't been watching the chat, my bad. I'm gonna look at this a little closer and just come down and get caught up. Good comment about true. I really like that part of the book where she talks about transparent, reusable, reasonable, usable, and exemplary. That question about, from Justin, how do you make the distinction between whether you're coding for the future or simply keeping your code well factored? That certainly is a $64,000 question. I think there was a phrase that I remember reading, and I don't unfortunately have my notes in front of me because they're all buried here in the Kindle. But this idea of what something cost today, you know, versus what it's going to, you know, what is it going to cost you to actually do some type of design versus just keeping what you have. And this notion of being able to get more use cases before you make a decision. But I don't know what other people, I think that's a really interesting topic, you know, making that choice. Would love to hear from what the panelists think about that, you know, how you make that decision between designing coding for the future or just simply keeping your code well factored.
There was also one other hint that Sandy Metz offered about that if something is going to cost the same, whether you add it now or if you add it later, add it later. So yeah, that's simple.
Mm-hmm. She also, this is outside the scope of the book, but she talks a lot about this in her talks. It's basically like, you're basically making a mess that isn't painful to work with. So it's not going to be perfect. Don't aim for perfection, but aim for things that aren't going to be painful for yourself to work with in the future. So if you get to a point where you're satisfying the message that you want to send or the message that you're trying to handle, that could be good enough.
Can you repeat that? Your objective is to make a mess you don't hate. Say, what was the phrase there you used again?
She says, making a mess that isn't painful to work with.
Isn't painful to work with. I like that.
Mm-hmm. That's not mine. That's all Sandy. I can't take that credit.
Okay, here's Justin was responding. Separation concern. We covered that. Justin mentions that test-driven development can help with coupling. If you need to create a bunch of test cases for one method, it can be a smell of too many dependencies, too many responsibilities. Well,
that is true. I'm sorry to interrupt. Sorry.
Please go ahead.
Yeah, I saw that comment. I said, yes, that is true, but and that is true, and it may be a sign that dependency injection is needed. Inversion of control is the same thing as dependency injection, and it means initializing your classes with the stuff that it needs to run. And so you see examples of this all over the book. Starting with the gear class, where she starts to inject those dependencies that a gear needs to calculate gear inches. And so, yeah, I heard, I forget if it was Ezra or Oscar mentioned something about, I think it was Oscar who said, yes, so you can get into trouble sometimes because it feels like your objects are too tightly coupled. I'm doing this, my hands are up here. And that tight coupling is, it's a pretty natural way to think, or it's a pretty natural, I guess, kind of corrosion that comes over your code over time. So you have to be really diligent to keep it at bay. And so dependency injection is an old technique. It's been around for forever. But the thing with the Sandy Metz book is that she's teaching you how to do it in Ruby. And so I totally identify with Ezra when he says, I was programming Java for 4 years, and I feel like reading this book, I'm really understanding OO in a different way. That's because you actually do have to understand it in a different way. If you're coming from Java or C# or any other language, you're probably familiar with a dependency injection framework like AutoFac or Spring. And when I first started writing Ruby, I was like, oh, I don't need to do this anymore. Or the opposite of like, where's the DI framework? And at least for a long time, one didn't exist. And so Sandy writes about how to do dependency injection, which is one of the solid design principles to keep that code loosely coupled, and as Robert pointed out, easy to test.
And it helps you, you can test those things you inject independently, or inject mock objects that would do that thing in the interest of testing out the thing that you inject to. I want to make sure we answered Meg's question. Can we define the concept of inheritance versus composition? I'm not sure if we ever did that, Meg. I'll give you my quick 2 cents on it. You know, it's one of the things that you'll see a lot is the is-a versus the has-a. You know, you'll see that a lot in literature. So inheritance represents a thing that is a thing, and composition, you know, represents something that has a thing. You know, so its behavior basically comes about because it has various objects inside of it. So I'm not sure if you, I don't know if that clears it up or not. Please, you can post in the comments, or you could just speak up.
That makes it even more confusing. Like, so when Sebastian said composition defines a class of the sum of its parts, it makes me think it's just like, it's just a class, like a class as normally written, like from, I don't know, you just create a class and it's just written from Ruby code, whereas like you don't have it inheriting from some other class and passing down different methods and things.
Well, you know, I'm the kind of person, I'm a very visual thinker and a very example type of thinker. So I'll give you like my 2 cents example wise, like the way that I just finished reading this book that we're discussing. And, you know, she starts out, I forget which chapter, where she's talking about, you know, the different types of bikes. And, you know, she starts out with an inheritance type of an approach where you have like, you basically, you know, you have your road bike and your mountain bike. And then she realizes, okay, well, hey, you know, there's an inheritance here. So we create a base class of bicycle, and then we, you know, create a road bike that inherits from bicycle, and then we create a mountain bike that inherits from bicycle. And then later in the book, she goes about and changes, kind of switches things up and talks about how, well, you could look at this as a composition problem, that, you know, a bicycle is really composed of this parts thing, you know, and it's the type of parts that determine what kind of bike it is. And she goes into a very different type of approach, which is composition based, where now you have a bicycle which is composed of a thing called parts, and inside that parts thing is basically all the parts that make up that bike. And so I don't know, does that add clarity, or that's sort of a,
so the bike is the class that is being composed, I guess.
Yes,
And
I can just
There's
the,
disparate
add or
components of the class that come together, right?
yeah, and I mean I can just add on a very basic level that inheritance is a language feature, and composition is basically the class has these fields. I think. I mean that's really making it more simplistic, less sophisticated. But like inheritance is a language feature. If you know how, if you don't know how inheritance works, then like it's a language feature. It's but composition is just the class has these fields.
yeah, like inheritance isn't the issue. That's something that I'm familiar with. It's just, I think when you learn in the beginning, you don't learn like very technical terminology. You're just like, and this is how you make it. And then later on, when you actually understand things more in depth, it's you get more into it. So that's why this composition thing is was confusing me. But I think that bike example helped clear it up.
she really, I mean, I think her book, sorry, pardon the interruption, that her book really takes you through a nice journey on this. So if you get a chance, you know, I forget which chapter she reveals that. I think it's chapter 7 where she starts to talk. It's after the inheritance chapter. She talks about how do you choose between inheritance and composition. And I think that's when she goes into this whole different approach. It's fun, you know. It's, well, you could look at it as fun. I'm sorry, who did I interrupt? Please speak up.
Oh, I was going to say, I think the reason we don't hear the word composition when we're learning it first is because it's so simple. Like inheritance is a complicated concept that has to be taught. All composition means, I mean, and I guess it's different when we're talking about behavior instead of data. But from what I learned when I was first learning, it just has these fields that these are just part of like a car has a tire, which is it's on the car. You can, yeah, like that.
Yeah, I guess it is something that's easy to overthink. Yeah.
Yeah. So, hey guys, I'm Sebastian. Nice to meet you. I
Hello.
think it's my second time after 3-4 years that I came to this meeting by the first time. That day, I remember that I got lost in the city. I think it was my second time in the city, and I got late to a meeting that you used to have close to Wall Street, if I remember correctly. But a few years later, I'm here and I'm happy to be part of this conversation. So I brought this topic today, and I'm happy we are having this conversation because this is pretty similar to the thought process that I personally have when I'm deciding between using inheritance and composition. And all of your points, it's basically what I've been experiencing when I'm dealing with this experience, with this issue. One way that I see it, and a few weeks ago, I've been trying to apply this is my team is looking for composition because it is more decoupling, but Sebastian is trying to use the big hammer because it's what he knows how to use it, and it might be a good fit for everything. And what I found is like sometimes we create really smart big parents that are capable to do a lot of things that probably their children don't need. And that's when composition is helpful. Basically, we just create a class and we include a few modules. I think we had a comment in the chat with those includes and mixins. A child doesn't have to be a child if it doesn't need all the behaviors and attributes from its parents. It will be okay and fair enough if we just add the behaviors and attributes that the child needs to do what it needs to do. That's one way that I have been putting that. It's still difficult. I think something that Richard mentioned before about interrogating your objects, it's something that I try to do all the time. Like, doesn't make sense this class to do this? Doesn't make sense to put this attribute here? Oh, is this class a tool or is this class an object? I'm always talking with my code, and my friends and coworkers are all the time like, Sebastian, who are you talking to? But it's just my thought process, and it's really helpful. So yeah, that's my comment, just to add my 2 cents in this conversation too. Thank you, guys. Bye.
Thank you. This is something, that I think we could talk about a long time. I think this stuff is really interesting. I don't want to, we could touch on some other things, but does anybody else want to talk about this whole inheritance versus composition, versus mixins? Anybody else want to talk about that topic?
No. I have a question for the book. Does she talk about threads?
This book does not talk about threads, as far as I know. I haven't finished the last chapter, which is about testing. But yeah, it's not a book about threaded programming, as far as I don't know if she has other books that talk about this.
I'll shamelessly plug the Well-Grounded Rubyist. 3rd edition does cover threads. It's more of a textbook than POODR is, which is, I think, really more of like a user manual or philosophy of writing good Ruby code. But you can definitely find information about threads in the Well-Grounded Rubyist. You can more than likely find it also in either the Head First book or one of the other sort of textbook focus, textbook genre of Ruby books.
Thank you.
Yep.
Cool. I haven't finished the Well-Grounded Rubyist, but I love that book, for all the, so That's a great book, Joe. A lot of different topics. You know, time evaporates really quickly. I guess we have another 15 minutes or so. I'm going to throw out a general question for all the panelists, and you know, please ask your own questions. But one of the things that really interests me, just in my own, I have the miles to on me, the wear and tear on me to have had various successful and unsuccessful experiences in designing code, and especially when you get multiple people together designing code. I'd really love to hear from any of the panelists about, you know, what they think works, getting people together to design code, or anyone else who's had, you know, a good success story, or even like, here's what you shouldn't do, you know, type of story.
I know all kinds of things that don't work. Sorry, go ahead, Meg.
I was just gonna say, I can give you a ton of examples because I am a contributor with Ruby for Good, and we do this but twice a year we'll do an event where it's kind of like a hackathon for a weekend, and work on like 5 or 6 different projects, and it's like a bare bones setup, and try to like finish out a project. So like at the time when I first did it, I wasn't like, I didn't know anything about code, but let me see. Yeah, there's this app. We had to make like a app that would work for a team of divers to log. They were restoring a coral reef, and they needed to like track their coral plantings, so they would like free dive under, and they wanted it to work on an iPad underwater without internet, and then save, and when they resurface and get back to land, they could connect to the internet and have it sync back to the computer. And luckily there's like 3 people with 15 plus years of experience on the team that could actually figure that out. So if you want to take a look in that, go ahead. That's the story behind that one. But there's like a ton of other projects on there with a whole bunch of design examples. But I know there was a ton of like web workers and weird crap going on in there. That was a couple years ago though.
Cool. That sounds interesting.
So I'll give it a go. I'm new to programming, and all I know is Ruby, and I just try to pair program with a friend, and her background is JavaScript, and we kind of just got into the discussion where like Ruby's only OPP and then JavaScript's only functional, and so like that was like, how do we talk to each other, try to accomplish the same thing, but we have 2 different frameworks coming back. So that was interesting. So we did Ruby last night, and tomorrow we're doing JavaScript. So I'll let you know next time how that goes.
That sounds interesting. There was one I would love, you know, please bring your questions to the forefront on design, but I had one written down here for JJ that really interests me, and I'd like to ask it to him. JJ, how do you recognize dependencies in code, and are there any tools that you use to quantify and discover those dependencies?
Richard, I'm glad you asked. So in my introduction, I mentioned that there is basically just one thing if you wanted to walk away from at least the dependency injection chapter with. It's this checklist that Sandy goes through. And it's really simple. It's 4 bullets. And I always found finding the issues would allow you to tackle them, right? You don't know what you don't know. So as long as you know how to find them, hopefully you've seen them enough and you know how to fix them. So Sandy at least talks about, so the biggest dependencies are when the name of another class appears within the class, the name of a message that it intends to send to someone other than self, the arguments that a message requires, or the order of those arguments. So you can kind of think about that. She specifically goes into gear and wheel and how a gear is calling on a wheel within it. And she basically breaks it down so that instead of calling on wheel, I think it was calling on diameter message in wheel. Instead of calling on wheel specifically within the gear class itself, you're breaking that out and passing in the wheel itself to the initialize for gear, right? So it's this basically destructuring of you found the issue and now how can I tackle it? And honestly, like that checklist, like it's at the beginning of the chapter, just that's all you need to know. Just walk away with that. Besides that, I mean, those really are the biggest ways to find dependency issues. I mean, the biggest thing is if your class or object changes a lot and would require a lot of other classes or objects to change anytime you change it, that's an issue. That is a prime example for dependency injection. You know that there's a way that you can basically decouple that message call. And at the end of the day, you can't remove the entire, you know, a gear needs to know about a wheel, but you can hide it. And again, it's all about how can you make a mess and be okay with working with that.
I think that's one of the favorite things I heard about how can you make a mess and be okay with that, because I think that describes a lot of what you struggle with. You know, when you're working on big projects, small projects, you got to get stuff done. Everything's a time crunch. Everything's about how much money you're spending. But I guess the other one of the points, I guess it's very common. I think I'm reading the chapter 9 on testing now, and just the idea of, you know, constantly refactoring to make sure that, you know, when you have the opportunity that you can extend your code when you need to. One of the things that I don't know if she actually says constantly refactoring. I think that's more in my head. You know, I'm constantly trying to refactor code I write to make it better. But when she talks about, you know, if you realize that you need to extend something, that, you know, the first thing you want to do before you start changing your classes or changing your inheritance hierarchy or composition or what have you, you know, make sure your code is, you know, refactored as well as it needs to be before you start extending it. That kind of made an impression on me too. Anyway, who else has like just, you know, random thoughts or interesting thoughts to share or questions?
No random thoughts, but I was going to throw it to Joe. Talk to us about your favorite books on software design. What do you think what do you think worked well in your career, or in, you know, what do you think is good?
Oh, sure. It's too bad we only have 7 minutes left, but you know, coming from where I came from, I had some years of software development experience before Ruby came along. And so I was really strongly influenced by agile software development, principles, patterns, practices. This is a Robert Martin book. Whatever you may think of Robert Martin personally, he writes extremely well, and he gets credit in Sandy's book as well. I think the sort of subtle genius of what Sandy did with POODR is she took a book she took sort of the Gang of Four design patterns book and the Refactoring to Patterns book by Joshua Bierewski. I'm not great at pronouncing that name. And this Agile software development Robert Martin book, and I've links to all of these, by the way. I can send them all over. And she said, and she hit on this piece that was like, okay, most of my audience is coming from a Java or a C++ or a C# background, because most people at that time, their first language wasn't Ruby. And I realize that that's different today. But most of us back then, we were either trying to write Ruby, or like me in 2012, I was writing Ruby professionally, and I was hoping that I'd be able to keep doing it. And we really didn't know. It wasn't a huge thing. There was Twitter and there was LinkedIn, and we were kind of like, okay, well, if these work, then maybe we'll all have jobs for a while. So they worked, you know, that part. I don't want to spoil the ending, but those companies did well. We all got jobs in Ruby, and now it was like, okay, well, we needed to unlearn some things. And so, yeah, I learned the single responsibility principle, and especially things like dependency injection and list call substitution. And for anybody that's new to these, don't be scared. Just Google solid design principles, and these will come right up, and you could read about them. They apply in any programming language, but if you spent most of your career applying them in a certain way, like a statically typed language, you didn't necessarily know what to do with them the next time, like in Ruby. For me, one quick story, and then I'll yield the floor. But for me, there was, I got to Ruby and I was like, holy crap, I don't have to write interfaces anymore. It was one of my first reactions to this was, this is a dynamic language. Like, I had spent so much time like memorizing the shortcut keys for extracting an interface from an object. And there was Sandy Metz's book to say, hey, yeah, you don't have to write interfaces, but there's a whole chapter on why it's a good idea. And by the way, you don't necessarily have to do it the way you did it. Here's the way you can do it. And that's why I think it fits so well. And that's why I think it took off. And the fact that it still speaks to all of these people that are coming and learning Ruby as their first language or even their second language. That's, I think, why it really stood the test of time. And, you know, we're still talking about it. It's almost 10 years later. So I can go on about other books, but I've got links for them, and you can check any of them out.
You're going to post your links in the chat?
Sure. Should I post them here in the chat? Yeah, we'll do.
Yeah, that would be awesome. Unless you want to direct us somewhere else.
I'm just using Rome.
I
You
noticed
just post them in the
has-
comments in the meetup.
I can do that. I'll give it to you here first, exclusively.
I noticed somebody posted Max Dana about the solid design principles in Rails in Go Rails. I haven't actually watched that video, but I've looked at a lot of content on Go Rails. I'm a big fan, so that might be a good place to pick up some of this knowledge that Joe is sharing.
Also, if you want to pick up some cool Ruby knowledge, you could do worse than just dropping Max a line. He's a sharp developer.
Say that again. You could do.
I
worse
said
than
if
what?
you want to pick up some cool things about Ruby, you could do a lot worse than just dropping Max Dana a line and saying hello. He's a little shy. He's not sharing his video, but he's a sharp guy.
Good to know. All right. He's got stuff on YouTube, or he's got a website?
Just check out his company, artspool.co, and he's done all of the architecting and developing on that site. It's all in Ruby. That's pretty fantastic.
artspool.co.
Yeah, that's right.
Okay, cool. I'm the kind of person that could talk and hear and listen to people talk about this stuff for a long time, but we're coming in on 7. So, you know, if you've been holding on to something and wanting to say it all night, this is your time.
This was awesome.
It's been a lot of fun.
Yeah, it's been a lot of fun. So we're actually going to continue this, and the next meetup in July, Andrew, I think you're here to kind of talk a little bit more about that. And there's a little baby. Tell us about what we're going to do in July since folks are here.
Yeah. I'm glad everyone had a lot of fun tonight. For July, we're going to continue talking about Sandy Metz's. You hear that? Yeah, we're going to talk about Sandy Metz's book, but I reached out to Sandy and she'll be part of the panel for the next time. So in the July meetup, Sandy Metz will be with us and you can even ask her for more things.
Very exciting.
Oh, that's
Really looking forward to that.
awesome.
That's very exciting.
That's pretty cool.
Is Zoom limited to 100 people? Because once news about that gets out, I know I need like a velvet rope, like at a club, and like a checklist.
Zoom,
I just
you
immediately signed.
got you. Well, definitely people who came to tonight automatically in, right?
Yeah. We
Right,
won't
that's
announce it on the meetup site yet until like the day before, but we'll be like secret guests. I actually
like
heard
secret
about her
DJ.
years before. I heard about her years before I heard about Ruby itself. She is beloved throughout all of programming.
It's so cool.
Yeah, I really enjoy her writing style, and I'm looking for her. I don't know if you all probably know that 99 bottles of OOP is on sale this month, or I think until June the 13th. So if you haven't read it, which I haven't, it might be a good time to pick it up.
July 14. Okay.
Well, one thing I was going to mention, like way before we leave or anything like that, such a huge thank you to all the panelists. I know it's been hopefully fun to read the book, but it's been just amazing to have you all here and be able to kind of answer some of the questions. Thank you so much for your time.
Thanks for having
appreciating.
us.
Yeah, thank you for having
Yeah,
us.
Really
Yeah,
awesome.
no,
Thank you
thanks.
guys. Really great.
Thank you.
And the questions, really appreciate people participating. Really nice.
I put in my social if you guys want to reach out to me or if you have any questions. I'm there.
Great.
I
Do
just want to
these-
say thanks a lot, Richard, for moderating. It was great. I wasn't on, but I was listening the whole time.
It was a lot of fun. Really had fun doing it. Thank you. Do the chat notes, do they get posted anywhere, or because there is a lot of good info. I've been copying stuff out, but there's a lot of good information in there. People's contacts, the books.
They do. So